Welcome to cutting tapers using the taper attachment. One of an engine lathe's more advanced procedures is cutting a taper. A taper is a uniform change in diameter at measured intervals along the length of the workpiece. The taper attachment features a slide that is independent of the ways. It's connected to the crossfeed screw. As the taper attachment sliding block moves along the slide bar, the crossfeed moves. In this video, you'll explore how to set up and cut a taper using a taper attachment. Parts of the taper attachment. Slide bar. The crossfeed follows the slide bar setting. This establishes the taper. Slide block. The slide block attaches to the crossfeed screw and moves the crossfeed. This creates the taper. Clamp bracket. The clamp bracket holds the taper attachment in place. Lock screws. The lock screws secure the slide bar setting. Adjustment screws. The adjustment screws allow you to set the slide bar. Setting the taper attachment. To set the taper attachment, begin by setting up the workpiece in a chuck or between centers. Use an indicator to make sure that the headstock and the tailstock are aligned. Set the compound slide, rest, 30 degrees to the right. Slide the taper attachment until it's lined up with the approximate location of the taper on the part. Lock the clamp bracket to the bed of the lathe. Move the carriage until the center of the compound is in the center of the slide bar. There are two settings on a taper attachment. On one end of the bar, you have the taper in degrees. On the other end, you have the taper in inches per foot. For this particular example, we'll cut a taper of 1.5 inches per foot. If the taper on the print is given per inch, multiply the measurement by 12 to convert it to taper per foot. Loosen both lock screws. Turn the adjustment screw until the setting on the slide bar indicates 1.5 inches per foot. Tighten both lock screws. Oil the slide bar. Checking the taper attachment setting using two indicators. The two most common methods for checking the taper setting on the taper attachment are the indicator method and the digital readout method. The dial indicator method requires using two indicators. The tip of one of the indicators is set at the workpiece's center. The other indicator measures the amount of carriage travel. Begin by setting both indicators to 0. Then move the carriage until the indicator on the center begins to move. This lost travel is called backlash. It's always present between the crossfeed screw and slide block that controls the crossfeed. We need to compensate for the backlash before every cut using the taper attachment. After compensating, reset both indicators to 0. Next, move the carriage 1 inch or 10 turns of the indicator. The indicator on the center of the work should have traveled 0.0625 inches. The calculations are 1.5 taper per foot divided by 12 to get the taper per inch. We move the carriage 1 inch. We have to take the quotient of that answer and divide it by 2 because we are measuring the radius and not the diameter or the actual movement of the tool in the x-axis. Next, we move the carriage back to the center of the slide and make any adjustments. This procedure may need to be repeated several times to achieve the proper setting. For this project, getting the setting to within 0.0025 of an inch is acceptable. That would be within 0.005 inch on the diameter. When the indicator on the center of the work shows that the compound has traveled 0.06 inches per inch, we are ready to cut the taper. Checking the taper attachment setting using a digital readout. It's important to check the taper attachment settings using a digital readout because it's much easier than using the indicator method. Set the taper attachment in the same manner as was shown earlier. Next, bring the tool tip toward the workpiece and stop about 0.200 in front of the part and about 0.100 off the diameter of the part. The digital readout is set to read the x-axis in diameter. Then, set the z-axis and x-axis to 0. Turn the crossfeed out until it begins to back the tool up and begins to move off the x-axis 0 location. This helps to get rid of the backlash. Reset the x-axis digital readout to 0 and move the carriage 1 inch on the z-axis readout. Next, move the carriage 1 inch. The x-axis should have moved 0.125 inches. The calculations are 1.5 taper per foot divided by 12 to get the taper per inch. Just as before, move the carriage back to the center of the slide bar and make any adjustments. This procedure may need to be repeated several times until the proper setting is achieved. Getting the taper attachment and digital readout setting to 0.125 plus or minus 0.005 is accurate enough for this project. Cutting the taper. To cut the taper, start by feeding the tool in for the first cut using the crossfeed. The cut is start 0.200 inches in front of the part and 0.100 off the diameter of the part. If you're using a digital readout, set both axes to 0. Next, turn the crossfeed out until it begins to back the tool up. This helps to get rid of the backlash. Reset the x-axis readout to 0 and use the compound slide to adjust the tool into position for the first cut. Take a trial cut and check the diameters of the taper at 1-inch intervals or by using a taper ring gauge if available. Make any necessary adjustments. Bring the carriage back to 0 on the z-axis digital readout. Bring the cross slide in approximately 0.02 past 0. Turn the cross slide back out to 0. This has to be done before making any cuts because it removes any backlash. Move the compound slide the amount needed for the depth of the cut. Take another cut and check the taper length using a ring gauge and calipers. Keep working until you've completed the roughing and the final finish cuts. Conclusion. There are many advantages to using the taper attachment for cutting tapers as opposed to offsetting the tailstock. Slight to fairly steep tapers can be cut using the taper attachment. Work may be held in a chuck or between centers. Centers may remain in line without distortion, as is the case with offsetting the tailstock. Both external and internal tapers can be cut using the taper attachment. You've completed cutting tapers using the taper attachment.